Okay, I guess we can start now. Only 18 people. Okay, no worries. Yeah. So, hello everyone. So this is basically a revision session. Yeah.
Okay.
Any topic you want me to focus on? Any week? Any particular concept?
Uh, yeah, so week 9 to 12, like week 9 mainly.
Okay, week 9. So just
Yes,
a
sir, in
second.
parent topic, parent.
Which topic?
J is a parent of I, this topic, sir. I don't.
Okay, week 9. So week 9 deals with
Uh,
a graph data structure, right? Okay. So cool. Okay, let me share my screen. Yeah, so is my screen visible?
Yes, sir, visible. Good
Okay.
evening, sir.
yes, sir, which is
So, yeah. So tomorrow also we have a session. So see, syllabus for end term is basically week 1 to 12. So we'll 12, we don't have any content. So we can say week 1 to 11. Okay. So if you look at, let me quickly revise first. We'll go to the week 9 also. So see, in the week 1, we have just discussed about the data set and introduction to pseudocodes, right? So this thing, in this thing we have discussed in week 1, different variable, what is variable, iterators, right? All this thing we have discussed. And if you look at week 1 to 4, we are focusing mostly on what? If statement, or we can say if else statement. Then we have a while loop, okay? And then we have few important, or we can say
sir,
properties.
nested iterations. We also like
Yeah,
in week
nested
1
while
to
loop
week 12.
also we have discussed. Nested if statement also we have discussed in week 1 to 4. Okay. So this is what we have discussed. And if you see, the best way to practice or revise the concept is basically solve the question based on this content. Okay. So cities goes like this only. By solving more questions only, you can revise the concept, right? So in week 5 to 8 is basically deals with what? A list and dictionary, right? So we should know all the important functions that we have discussed in this particular course regarding the list and the dictionary here. Okay. And about
Sir,
the if, yes,
what is the best way to revise the whole course?
just solve the questions, previous year question. Okay. That's it. Because by solving questions only, you can revise the concept. There is no theoretical part in the CT course, right? So mostly if you just solve the question, so you can see I'm planning to discuss the previous term, like January 24 term, end term paper. So through that, all the weekly content we can revise. Okay. So we'll discuss week 9 as well. We'll see. Okay. So week 9 deals with what? A graph theory, right? Okay, fine. So I will discuss few questions. Any question you want to discuss me from week 9, from practice assignment or grade assignment? So we can cover entire week 9 first. Okay. Yeah, okay. So if you solve the previous term also, that is also fine. Okay. So let's try to solve few questions one by one, and then we'll revise the concept. And then we'll solve one question from week 9 also. Okay. So simply we will start with this first question here, right? So is this paper discussed by any TA or instructor, January term? Anyone? Okay, fine. So see, just read the question here. I'm audible, right?
Yes, sir.
Yes, sir.
Okay, fine.
So can we use mock assessment which was given
Mock
for
test.
intern? Mock assessment.
Yeah, you can go through that as well. Okay. So let B be any dictionary whose keys are string and the values are integers. Let for each key A in D, what is D of A is the letter count of A here. Okay. So choose the correct statement about the dictionary D. So what is dictionary? We store key value pair here. We have a key, then we have colon, then we have corresponding value. So key one corresponding value, then we have key two corresponding value like this. Okay. So this is basically dictionary having key value pairs. Now, few important functions regarding the dictionary is basically what? Keys of D. So when I say keys of D, so this will give me what? Yes, anyone?
A value?
List of all.
Value, yes, sir.
List of all keys. List
Yeah,
all
list of
keys
all.
K1, K2.
in dictionary. For example, for this case, we have list is K1 and K2. Okay. This is a function of keys D. Then we have is key function here. Can anyone tell me what is key function? It will take D and K as an input.
It tells
If-
whether the
Yes, sir.
key K
One
is
is
there in the dictionary D.
Yes,
one
sir.
Yes.
is one
So
is there in the
yeah.
dictionary.
So this is to check whether there is particular K or key is a part of this dictionary or not. So if I say is key D comma K3. So for this D we just have K1 and K2. We don't have K3. So K3 is not a key of this particular dictionary. So this will give me false. Okay. If any key is present inside a dictionary, let's say for example K1 here. So K1 is present inside a dictionary. K1 is part of the dictionary D. Then we can say it is true here, right? Is key will give me either true or false. You can see like that. Okay. So it is simply checking whether
Uh,
this key
Sir,
is
what
present
is
in the
it?
dictionary or not. Huh?
Sir, in the last statement, what is it written like first word?
Which one? Here.
Yeah, last statement.
Is
You
key
have written.
only. Is key.
Okay.
So again, I'm writing the function name is key D comma K3. So K3 is not a part of this dictionary. So this will give me false. And here K1 is part of this dictionary. You can see here. So this will give me true value. So is key function will always give me a Boolean output that is true or false. Is of D will give me list of all the keys inside this particular dictionary. Okay. Now let's see.
Sir,
Fine.
is not key function is that this particular value is not a key in the dictionary.
Is not key is not a function we don't have. Only is key. Only we are checking whether it's key or not. That's it. It will give me either true or false.
Sir, in pseudocode it was written like is not key
No,
d
no,
comma
it was
key.
like that. Not of, then is key. It was like that, right? D comma key. So not is written outside this particular function. Now, what does this mean? What is the value of this particular function? Either true or false. Okay. So not of true will become false, then not of false will become true like that. So what is the value we are going to get? Simply not will take the negation of that. Instead of true, that will be false, and of false, it will be true like that. Okay.
Okay, sir.
So, yeah. So let's see the question here. We have a dictionary D, and let's see what does this thing is saying. For any two keys K and Y in particular dictionary, D of X. So what is this D of X or D of K will give me corresponding value for this particular key inside this dictionary. Now D of X is not equal to D of Y. It's always true. Is this true for two different keys? Is the statement correct?
No. Yes, sir.
No.
Yes, sir.
All.
Values can be same.
So it is not
So
necessary. It will same. It will be
it's saying
same.
values are not same basically for two different keys, right?
Yes.
And it always true. It's always true. No,
No,
value can be same as well, right?
Yes,
So
sir.
option
Value.
A is not correct. So two keys can have a same value. There is no issue with that, right? Now what about the B here? is key, d comma 1 is true. So what is d comma 1? But if you look at what is dictionary d here, for each key a in d, d of a is basically what? A letter count of a, right? So this will give me
False.
what? A and this
False.
letter count here.
It is
So
false.
right, so a is basically a what string and the value is basically integer. So is this true?
No, sir.
No,
No,
false.
this is basically false because it will take the string as a key here, but here we are using one. So anyway, one is not a part of the key, that will give me false. What about C?
How it is false?
No, see, for a dictionary D, you can see keys are the string and the values are the integer. So keys, basically, this side is basically string value. This is basically integer values. Okay. This value side, you can see values are integer. If you look at D comma 1, so this must be a key here. But key cannot be an integer here, you can see, because key are string given in the question itself. Okay. That's why it is. So this will give me false because one cannot be a key in the dictionary. Okay. What about C?
Is it true?
It can be It's true false. because
Read.
Sir,
keys are
false.
all
False.
strings.
It's
So
false.
list of all the keys it will give, and keys are strings, so it is the list of strings.
Yeah.
Yeah.
So
So
Yeah, it is a list of strings.
yeah. So this is basically what the list of keys of this dictionary D. And what is the keys? All are the string values. So we can say list of string. So option C can correct here. What
Yes.
about this one? Is this correct? String and the corresponding letter count you can see here. Is this
Yes,
correct?
it is true.
7 we have characters, right? So output is 7. So D is also correct here. Because what is given to us? A is basically what? A word, and you can see corresponding value represent what letter count here.
Yes, sir.
So
It is
for
correct.
this particular cricket, 7 is the letter count. Yes. What about E?
No, keys can't be duplicated.
Yeah. So all the keys are unique here, right? So every key in the dictionary must be unique. So key can be duplicate. So option E is not correct. Only C and D are correct here. Okay. I hope the concept of dictionary is clear now.
yes, sir.
Okay. Great.
Yes.
Let's try to solve this question here. Okay. So the following pseudocode is executed with shopping bills data set. Okay. Assume that customers' names are distinct. Okay. So we have two variables a and n equals to 0. While table 1 has more rows, so we have this while loop. Read first row x in table 1, move x to table 2. Okay. While table 1 has more rows, read the first row y in table 1, and then we are performing these operations here, right? So while will start from here, will end here, and this while will end here, like that. Okay. So it's basically nested while loop, you can see, right? So what we are doing here, if I have the table, let's say for example, I have this number of rows, okay, 1, 2, 3, 4, 5 rows are there. Now what I will do, I will go to table 1, let's say for example, table 1, read the first row. So this is my first row, I'm calling it as X. I will move that X to table 2. So table 2 is basically initially empty. I will move that X in the table 2, okay. Then we have while loop. While one more time, table 1 has more rows. Yes, table 1 has more rows because after removing 1, we have the second row as the first one. Can we say like that?
Yes,
Yes, sir.
After removing the first row, you can see in the table 2. Now my first row in the table will become my second row here, right?
yes,
Now this will be my Y, right?
yes,
Now what we are checking here, if x dot customer name is equals to y dot customer name. If customer name is same, then we are going to increment the value of A. Otherwise, if customer name is not same, we are moving that particular y to table 3 here. Let's say, for example, we have table 3. I am moving that into table 3. If customer name is not same. If customer name is same, we are going to increment the value of count. And then we have to remove that particular row in the table 2 like this. Okay. And let's say, for example, customer name is not same for the second and the first row. So what will happen? Not same. So we'll go to else block.
We
We'll
go to,
move that.
yeah.
Yeah. So we'll remove this one. This y2 here, x1, let's say for example, first row. Now what will happen next if I go to else block here? Where to go after
So,
this else
sir,
block?
sir, if A is greater than N, then N is equals to A. That means
No.
A is the pair of all the customers which are same basically in that
Oh,
shopping bill data set.
okay. Yeah. So see, we are inside this particular while loop. We cannot go to line number 15 unless we complete this entire while loop here, right? So this is what we have done for the first iteration here. We have moved that particular y to in the table 3. Now we have to go for a next iteration here. In the next iteration, already we have removed the 2. Now we have 3, right? So we have this 3 here, third row, that is also basically y. Again, we are comparing that particular y, that is y3 with the x. This is basically x here. So what we are doing here, in the nested while loop, we are going to compare the one row. This is one row with every other row. This is what we are doing.
How many times we have a same customer card? That's like
Yes. So let's say, for
Pair
example,
of same.
customer name is Piyush here for the first row. So second row not Piyush, third row not Piyush, but fourth row is Piyush. So this will get increment, right? But again, we have
Yes.
to check for fifth row also. Fifth row can also be Piyush, right?
So,
So
sir, if
in
we
this
move
way,
all the cards to table 3 and then we'll finish all the cards, then A is the value of all the pairs which are basically the same customer.
yes, customer name, right? So if you look at here, I am going to compare the first row from this outer while loop with all the remaining rows from the table here. This is what nested while loop is. Okay. And if you look at out of these 5 rows, if 3 rows is having Piyush, what's the value of A then?
Uh, is 1.
5 or 5. If we have 5 views, we have 5 value.
Yeah, if I have 5 POs, we have no. If I have we 5
No,
POs,
no.
we have the value of 2. Yeah, 2.
If we out of 5 rows, if we have 3 same name here, let's say for example Piyush. So this will match with this one, so it will increment by 1. Again,
3.
this
Yeah,
will
yeah,
match
sir.
with this one, again increment by 1, that is basically 2 here,
So,
right?
yeah.
Shopping bill of same customer.
Yeah, shopping bill of same customer, you can see customer name. Now, once it gets matched here, we are moving Y to table 2. If this gets matched, we are moving this particular here. If this gets matched, we are moving this particular here, right? So if the customer name got matched, we are moving that to a table 2. Let's say, for example, table 2 and table 3, sorry, row 2 and row 3 is having different name. Okay, let's say, for example, Ram and Sham. Okay. So once we got the matching for all the pairs, we are moving that toward table 2. But what we are doing here at the end, you can see we are moving all the rows from table 3 to table 1. In the table 3, that will be the rows which didn't get matched in the previous iteration. That is basically Ram and Sham. Then we'll compare with Ram and Sham like that. Okay. But you don't need to go in this detail. Just observe what we have done here. So this will count what? What A will give me?
Number of
Number
Number
of
of
pairs
shopping
of the
bills. Number
same
of shopping
same
bills.
customer. No.
number
Number
of
of pairs
pairs.
of the
Uh,
customers which are same. Yeah.
Number of pairs we can say, right? Now, once we have
Yeah,
gone
yeah.
to the inner while loop, we will go to here. A greater than n. What is n here? 0. A is basically 2. So we have to replace n by 2 here, like that. And then A is becoming 0. And we are removing all the rows from table 3 to table 1. And then we are going back to a table 2 here, table 1 here again. Okay. So again, same process will get repeated for a different customer name here. This is what we have done for one customer name matching here. Okay. So this will do for all the customer name matching like that. So if you observe, if we have, let's say for example, 10 such rows, if we have 10 rows in a table, and let's say for Piyush, we have 3 rows, then for Ram, we have 2 rows, then for Sham, then we have 5 rows, for example. Okay. Now here total 10 rows, right? So for Piyush, it will be value 2 here, right? So you can see 2 greater than 0. Yes, that is true. And equals to A, that is basically what 2 here. We are going to update.
Sir, why we have value 2 for POs? Because if one pair is succeed, value is
Yeah.
3, there is
Number
3
of
rows of
pairs.
name POs. So then
Yes, number of
one pair
pairs.
is one pair is equals to like one, right? If the value is if the same name Piyush comes three times in the shopping bill data sets, then
Hmm.
we have the only one pair, right?
See, if this customer name got matched with row number 4 here, this is not satisfied. We are going to increment the value A by 1. Now we have removed
Yes,
this
sir.
Y. This we have removed this row. But what about the next row also, right? So this will get matched with this also, na? So again it will
Sir,
get increment.
yeah, again, it will. I am not able to understand this. Sir, if there is one customer named Piyush, right,
Hmm.
and
Hmm.
we'll move that to table 2. Then we again find that name Piyush and we'll match it with table 2 value and we'll find that this is the same customer and we'll increment the value of A by 1. Then
Yeah, so
again, if we find
huh.
Match.
Piyush, we can't like increment that to 3, like to 2,
It's
Yes,
right?
like
yes.
Because
matching
it
with
is only
Piyush's
one.
too.
No, not
It,
this
it
Sir,
is
we
one. We
are
are
only
not
not
one.
checking pair. Simply,
Pair.
we are not checking pair. We are checking
We
the
are
how many times that
we,
same
we
customer
are
appears in card. I think.
no. See, let's say for example, we have one person, let's say for example, usually 3 times in the table, right? So if this is the X, so it will get compared with Y. Once got satisfied, we have to remove Y in the table too, right? Then again, this will get compared with Y here. Again, we have to remove in the table too. This is how we are comparing. So if we have three rows with the same name, so our output will be what? We are forming a pair here, 2 pairs here, okay, like that. Or we can say, okay, we'll discuss this one. You can see n represent what, okay? So see, if we have 3 people with the same name, the value of A will be a 2 in that case. This is what we observe. So what I'm saying, what about the RAM here? Again, RAM will match with the one more RAM here. That is basically value of A will be 1. But from the previous iteration, we got the value from Piyush is basically 2 here. So is 1 greater than 2? No. So this will not get updated. The value of n will be 2 only from the previous iteration. Again, the value of A will become 0. Now we'll go to table 1 again. Again, we'll find out the customer with the same name here. Let's say, for example, Sham in this case, 5. So in that case, answer will be what? Here, A will be a 4. Right? Now the value of A becomes 4, the value of n becomes 2 only. Now this is true. Now we are going to update this with A because n equals to A, that is basically 4 here, right? Now if you observe
So
what is
then
this one?
then
Huh,
this is the most frequent customer.
yes. This is what we can say. More, yeah, this is what we can say. Let's see here. Is this number of bills issued to a single customer or maximum number of bills? In terms of bills, we are asking here. Okay. In terms of bill. Now tell me in terms of bill.
maximum number of bills to a single customer.
Yeah. So for Piyush, we have 2 bills. For Ram, we have two, like let's say for example, 2 for Sham, we have 4 like that. So maximum number of bills you can see. Issued to a single customer, number of distinct customer data set, no. Maximum number of customers who purchase item from the same shop, we have not talk about same shop in the code anywhere. So option B will be correct. Let's see option B is correct or not. Yeah. So simple thing here, right? We are simply comparing the value of A with different customers here. How many times that customer name is been there in the shopping bills? Or we can say number of shopping bills also, right? Number of rows is basically number of shopping bills only. Okay. So option B is correct here. Maximum number of bills issued to a single customer. Is this correct? Is this fine?
Yes.
Yes.
Yeah. So what we have discussed, the working of nested while loop here. So we can compare one row from the outer while loop with every other row in the in inner while loop. This is what we have discussed. Okay.
Sir? What was option A?
Minimum number of bills.
Okay, okay.
So if I simply change this to this arrow like this, and instead of n equals to 0, if I put let's say 1000 here, in that case option A will be correct.
Yes, sir.
Right?
Got.
Yeah.
Sir,
Huh?
This is maximum number of bills, but it is not the exact number of bills, right? It will be
Yeah,
one less
exact
than
not.
this.
Yes, yes, correct. Because we have started the counting from 0 here,
Zero.
right? If
Yeah.
I take 1, then in that case we'll get number of bills belong to the same customer. Yeah. Yeah.
But so why we are not taking one then?
Yeah, if we want to perform that particular task, which who is that particular customer, then we can start with 1 here also, right? That is not the issue, right?
Okay.
But in general, if we say we counting, here it's we are dealing with the pair, so we should, if you want to include that customer also, then we have to start with 1. Okay.
Yes, sir.
Okay, let's see.
So if we
Okay,
take one instead of zero, how it is correct, right? It will become if we find first name Piyush, then it will become two already.
no, in that
But
case, this will be 3, this will be 2, this will be 5 only, right? So value of A will be 3 to 5. And at the end, we are going to get what maximum number of bills only. We are not interested in the number of bills in this particular question, right? How many bills? We just want a maximum or minimum number of bills for single customer, right? Like that. Okay. So in the exam, you can expect this type of question because data is not given to you, right? So we'll ask what A will represent, what N will represent, like that. Okay. Okay. Let's see here. Now let's discuss about this question here. The X and Y with 2 rows in the scores table here. We call X and Y partially matching if student X and Y either have same age, sorry, same gender or from the same city, but not both. To read the question carefully, when we can say X and Y is partially matching if student X and Y either have same gender or from same city, but not both, right? So let partial match X, Y be a procedure to find whether X and Y are partially matching. Choose the correct implementation of the procedure partial match. Okay. I hope the required thing is clear to you, right? This statements.
Yes.
Now, is this correct? Option number A. Will this satisfy this particular requirement here? We have two
No, sir.
players, X and Y. Now tell me
No, sir.
why no?
Sir, it is.
But because if it is saying that if A and B both are true, then it will return true. So that's why.
We are going to return true when both A and B are true. So when both A and
So
will be true,
if it
when gender is
yeah,
same and town and city is
Town
also
is,
same, right? Yeah.
yes.
so
So
sir, if A or B is true, then this option should be correct. There is uh, or instead of and
okay,
in
if
the
we replace
statement
by
9.
or, will this be correct?
Yeah, yeah, sir. I think
No.
so.
What about this condition? Not both.
So,
So
that's
the
why I'm saying
no, if we put or here, so if A and B both are true, so that will also return true, but we don't want that, right?
no, sir. If we put or, that means only we will be correct or B will be correct, not both.
No, no. Here inside the if condition, if I put A or B, right? So this will be true when A is true or B is true or both are true, right? But we don't want that
No,
condition also, but not both. We don't want the person from same gender and the same city. We just want or not both, right? So
So we
that will
put
not be a
equal,
correct.
not equal to sign.
We'll see. We'll see. Let's see. Let's see the option number B here. Is this correct? I guess same code, just we have replaced with or. Yes, false,
yes,
false.
sir. Yes, sir.
This will not be correct because this will satisfy my first two condition, like uh, either have same gender or from the same city. But what about this condition? Not both. When both the conditions are satisfied, in that case
Sir, or
also this
is
will return
used.
true.
Sir,
Huh?
or is used that either of A or either of B is correct, but not both.
No, no. Or is used for
No,
either A or B
or
or
is
both.
used TFFTTT.
Yes, this is what it is, A or B. If A is true or B is false, so answer will be true. If A is false or B is true, answer will be true. And if even if both are true, this will be true. So and if any one condition is true, this will be true. Okay. So
Yes, sir.
this is what OR is. In the case of AND, both the thing must be true. Then only the entire condition is becoming true. Let's see option number C.
Yes, sir. Correct. It is correct.
Now see here. We have initialized A and B to false, right? Now, if gender is matching, this will be true. If gender is not matching, A will be false, right? If city is matching, B will be true. If city is not matching, then B will be false. This is what we have initialized the A and B, right? Now, what is the case here? You can see this particular condition now. Now, first, let's go with not of A and B. And let me write it down here also. And A or B. The first case, gender must be matching and city should not match. So A true and B false. Will this be true? Entire condition will be true because then only we are going to return true. A true and B false. Tell me, is this true for this one? So A or B will give me what? That will be true only because A is true. So this will be a true. What about this condition?
A and B is false, not will be true.
Yeah. So true and false will be a false and not a false will be a true. And true will be what? True. So this is what we want. So it is going to return true for this condition. Next condition is basically what? A will be false and B will be true. And still I want true in that case. So will this return true also in that case? In second case?
Yes, sir.
Because here A or B. So anyway, false or true, that is basically true only. Here, false and true will be false, and not of false will be again true. So true and true will be true. So satisfy my second criteria also. What about this one? A will be true and B will be true. In that case, I want to return false. Now, what about this one? Is this satisfying for this third criteria? When both
Yes,
are
sir.
true?
Yes,
Yes,
sir.
sir. Because not
Yes,
of
because
T
if you observe,
Not
this will be true, this will be true, but not of T will be false, false and true will be false. So this will return false in that particular case. Okay, that is correct. Right, so option C looks correct here. Any other possibility here? When both the things are false, what will happen in that case? A and B both are false. Then it should return false. We have to check for that condition also. If both are false, then what will happen? A or B false, so and false. Here also false and false will be false, but not a false will be true, but true and false will be what? False. So this will give me return false. So option C is correct,
Sir,
satisfying all the criteria.
if
Huh?
not
Yes.
A and B, sir, if not A and B implies that both A and B are false.
Sorry. Can you repeat it? Not A and B implies both A and B are false.
Yes, sir. If not A and B, which is written in the statement 9,
Hmm.
implies that uh, they're both A and B are false.
No, no. Whatever the output you are going to get here, A out of A and B, so not is simply a negation of that. If this is giving me true, not will give me false. If this will give me false, not will give me true. Okay. So always in this particular case, first evaluate the bracket, then negation, then and here like that. Okay.
Okay.
So option C is correct. Option D can also be correct. I guess it's MSQ or what? MCQ. Let's see. Option D, is this correct? True, true, false, false. Here,
no, sir. It's
if,
it's
if
incorrect.
A is true, B is false, what will happen in that particular case? See, A and B, so it will be a false. So false and whatever the value we are going to get, that will be false only. So in that case, it will return true, right? satisfying my this criteria. Right. Sorry, no. True or false will be true, and not of true will be a false. False and false will give me return false. Yeah. So not satisfy my criteria. So option D is not correct. So only option C is correct. So in such scenario, you can just consider these particular cases A true, B false, considering this given statement here, right? This is what we are checking here. Okay, like this. So read the question carefully, then you can easily eliminate the options. Anyone, any doubt in this question?
Sir, approximately how many questions will be there in the end term?
20.
Okay.
Okay.
Sir, I have doubt in not criteria.
Okay. Yes, what's your doubt?
Sir, if not A and B,
Okay, not A and B. So not A and B. So see, here we got the value of A and B, okay, from the above lines. Let's say, for example, this true or this false, right? Now see, the value of A is true, the value of B is false, like that. What are the value we are going to get from the above lines that you have to consider? It's a variable, right? A and B, right? So see,
yes,
the
sir.
output is what? Please mute. Yeah.
Output is false.
Output is false, but false is output of A and B, not of this one. Now, not of false will be what? This will be true. Okay,
True,
so
yeah.
simply negation of that. If both are true here, so A and B both will be a true, right? So not of true, so that will give me false here. Okay,
Okay, sir.
yeah, okay, great. Let's see question number 4. Very good question based on the list concept, right? If you understand this particular question, then concept of list will be clear. Okay, let's see. We have the question based on the words data set. A0 flag is equals to true. Then we have in list is basically what empty list. Out list is basically empty list here, right? While table 1 has more rows, read the first row X in table 1. Now see, if flag. Now what is this flag here? Yes, anyone?
Flag is true.
True, sir. Flag is
Initially flag is true. So what are the value of flag is there at this point of time? We have to consider that. So here we just have true here. That's it. So already condition is true. So if flag is true, then what is this one? What we are doing here? In list is equals to x dot word. So if you remember the words data set, we have few a sentence and the letter count here. So if you remember, the first sentence is basically what? It was Monday morning. Okay, this is the first sentence we have. It was Monday morning. Now, in list is initially empty. Now, what we are doing here? We are taking the first row from the table 1. In the table 1, it is the first word here. So, this will be what? I am going to add it in the in list. Flag is set to false. See, flag is set to false now. Okay. Now, is this condition correct? What about line number 9? Because these are the different if statement. Words end with the full stop. It is not ending with a full stop, right? It is the first word basically of the sentence. Whenever you see this word ending with a full stop, it means what? The last word of that particular sentence ending with a full stop, right? So this is not satisfied here. No, we are not going to do anything. Please mute. I'm getting a background noise. Okay. Now we are moving that X to table 2. Now we'll go to line number 3 for next iteration. Next is basically what was here. Now tell me what will happen in the case of next what was.
It will be stored in the in list.
We will not store in list
It is
because
will not
flag is
store in
false.
Flag is
Flag
false.
is basically false from the previous iteration, right? If
Yes.
flag is set to false, this is false. We are not going to do anything. We'll go to here. Again, not ending with full stop. We'll move to table 2, go for a next word. So doesn't matter what you will do here. what we are doing here, what the in list will store for every sentence, can you tell me if you observe the pattern here?
First word of the sentence.
Yes, because even if you go with the Monday, again it's a false, so we are not. It's also not ending with full stop. We'll go here. Now next word is basically morning. Okay, in the case of morning, what will happen? Again, flag is basically false only. But what about this statement now? Is this true? Morning ending with a full
Yes.
stop? Yes.
Yes.
Now what we are doing here? Outlist equals to outlist, that is initially empty, plus inside the bracket we have in list. In list will have what? It.
First word,
Now,
yes, sir.
First.
plus x dot word. What is that?
Last
Morning.
word.
Last word of the sentence.
Morning, yeah,
Morning.
last word of the sentence.
Is this correct?
Morning, yes.
Is this correct?
Yes,
Yes,
sir.
sir.
Yes.
No. What I have written, it instead of in list, but this is not one. This is basically a list here, right? We have to put inside the bracket here. Are you
Yes,
getting
sir.
my point? So
Yes.
this
Yes.
bracket, outer bracket of this one, in list is itself a list here. You can see having only one word, right? Now plus we have morning. So output of this will be a what? We have it, comma. Then we have to merge these two lists, it, comma, morning, like that, and then we have a outer list. This one, okay. What is this one?
Outlist.
List of a list,
List.
we can say,
List of
Yes,
lists.
sir. List.
Yes, sir. List
right?
of list.
So this is what we have. We will get after what? First sentence. Now what's the value of a here? 0 plus 1
One.
will be 1. In
Yes,
list
sir.
will be
One.
empty now. Flag will be true. Now we'll
Yes,
move
sir.
that to table 2. We'll go for a next iteration. In the case of next iteration, the value of flag is basically what? True here, right? Now tell me directly what outlist will store for the next sentence.
First and last word of sentence.
Yes.
Yes, sir. First and last
So,
word of that sentence.
so can I say this will store first and last word of the each sentence?
Yes, sir.
Yes.
So if I talk about the out list here, this will be like this. So it's the first list. So sentence one, last here, last word, then comma, again sentence two, first word, then sentence two, last word, again, then sentence three, first word, sentence three, last word. Can I say like this
Yes.
Yes.
for out list? Because we are keep adding that, we are keep merging that, because for the second iteration, out list will be this one. So we are merging that list into this one. Okay. So this is basically list of list, and every element inside this list will represent the first and last word of each sentence. Am I correct?
Yes.
Okay. If you understand this one, let's see. The value of length, outlist, and a will be same. Is this correct?
Yes, sir. It is the number of sentences it will give.
So number of words ending with full stop is number of sentences. So a will give me that. Outlist will also store that much number of pairs, right? Of first and last word. So length will give me that number of elements. So in this case, we have 3, and the value of a will also increment 3 times for the 3 ending words, right? So can I say option A is same? Sorry, option A is true.
Yes.
Let's see, option A is true. What about B?
So not correct.
No, sir. First and
No.
Why
last
not
word.
correct? Yeah,
First
last
and
word
last.
is
So
missing.
first and last word.
What about C? Not correct. What about D?
Yes, sir. It is correct.
A and D is correct here, right? Let's see the answer. Yes. Right? So simple question, right? Shouldn't find it difficult, but if you observe, if you go step by step, it is simple one only. Right? Nothing much. So try to solve this type of question again. I'm solving this question, so that's why. But if you try to solve by your question, if you try to solve your question, then you may come across more doubts, right? So try to solve this question again, like this type of question. So this is the main thing, list of list here. Okay. Rest everything is, I guess, fine because these two are a different if statement. Okay. Okay. Any doubt in this particular question? Anyone? Okay. Great. Now here we are dealing with what? Recursion. In the week 10 or 11, we have discussed the concept of recursion. Very, very important topic. Definitely one question will be there from this particular topic in the end term. Okay, in every end term, there is one question and you can expect one question from recursion as well. So let's see. We have a pseudocode given below. In a list of positive integers. What is this one? List. Sorry, it is not a list. It's a positive integer. Okay, this is a list and it's a non-empty list of positive integer. So one is list, one is basically positive integer. Okay, and we are calculating that. But what is calculate? Let's see line number 2 here. If length is 0, we are going to return a. Otherwise, we'll go to else block here, right? First of L, then we are going to return this one. So again, we are going to call the same procedure here. That is what recursion is. Function inside the function, right? That is what recursion. Now, first, let's discuss about the first and last and this init and the rest functions. If I have the list here, let's say, for example, 2, 4, 5, 7, 8. So quickly revise the concept of list here. So here we have few different functions that you need to remember. First one is basically length. We all know what is length, number of element in the list, right? What about first of L?
First element of list.
First element of the list. So only element here, not the list. Third is basically what? Sorry, last of L, last element of the list. What about init of L? Yes, anyone?
Except
Except
last.
the last
2,
one.
4, 5, 7.
Yeah. So init means except the last one. So 2, 4, 5, 7. What about rest of L?
Except the first one.
Except the first one. 4, 5, 7, 8. Okay. These 5 functions. And then we have members function. Members, L comma, then some particular value. Let's say, for example, element. What this will give me? We are checking whether this element is part of this list or not. So if I say members L comma 8. So 8 is a member of list L. Yes. So again, this will give me Boolean output, true or false. So in this case, 8 is a member, so this will give me true. Instead of 8, if I put 9, 9 is not a member of the list, that will give me false. Okay. So you have to remember this 6 function. Anyone, any doubt in these functions? Okay, great. Now let's try to solve the question. Yes.
If you can just revise the like how we append the lists also.
Yeah, so you can see in the previous thing, right? So plus plus here. So if I have one list, let's say 2 comma 4 comma 5, then we have plus plus, then we have 1 comma 3. So this is what we are merging this. We are merging two lists, 2 comma 4 comma 5, 1 comma 3, like that. Okay. Appending the element you are saying, right?
Yes, sir.
Yeah. So it's merging and appending also happens same way. Instead of two lists, we are simply adding 2, 4 comma 5 previous list plus plus, and then we have that particular element. Let's say, for example, I here adding that. Okay. So in CT, we
And sir,
don't use any
order.
function here. Huh?
Sorry, sir. So the order, how the like if I change it the order, then it will be appended from like basically from
Yes,
that.
yes. So if I say for I in the list L, L is basically, let's say, this one only. 2, 4, 5, 9. And then I'm adding in the new list. Let's say, for example, P. So P equals to P plus plus, in bracket, I'm putting I here, right? So if I put I on this side, so P is initially empty. So this will get added in this particular manner only, 2 comma 4 comma 5 comma 9. But if I say P equals to I plus plus P, in that case, we are going to add in reverse side. So first 2 will get added, then we have empty. So that will be a 2 plus plus, next element is 4. Then that will be a 4 comma 2. Then plus plus, next element is 5. 5 plus plus, then that output will be 5 comma 4 comma 2, like that. Okay. So here you can see order matters here. If I plus plus P is different than P plus plus I. Okay.
Thank you, sir.
Okay. So this is about the list, and for list to iterate the list, we use the for loop here. So for each I in this list, for every element in this list, I want to add that element in the P list here. This is what I have done. Okay, so we'll solve few questions on the for loop as well in the upcoming questions. Okay, but as of now, let's try to solve this question here. Okay, so different question here. So this is a procedure given to us. How many times procedure calculate we call including the initial call in the line 1? Okay, so let's see. Length of list minus 1, length of list plus 1 depends on element in the list. Is option all the four options clear? Length of list minus 1, length of list plus 1 depends on the element in list. Let's see the code here. Now tell me which will is the correct one. How many times this will get called? Called means executed, including the line number 1.
Length of list plus 1.
List L, let's say for example, a positive integer. So 2, 4, 5, 6. Let's say for example, we just have 4 elements now. Integer is basically, let's say 7. Okay. So 7 and then we have a list. So 7, then we have a list. So length of is 0. No, we go to else block. A greater than first of L. So first of L is basically first element only. So we will going to store A in the first element. Then we are going to return this one. Now what we are doing here? What is this?
Rest of L.
Rest of L.
Means we are removing what?
First
Uh,
element.
First
First
element from the list, right? In the next iteration, the output will be the input will be this one 4, 5, 6 instead of 2, right? 4, 5, 6 instead of 2. So first we have called this one, then we call here again, right? Again we'll check for this one, again not 0, again we go to else block, again we'll try to compare, again we'll go to return, again we'll see here, again we'll get removed, again plus 1, again we'll go back, again this will get removed, plus 1, again go back, again this will get removed, plus 1 here, right? So how many times? Length plus 1 or what?
So length. Number of
Plus
Even
elements.
Yeah,
even
length.
if the even if the list is empty here, let's say for example at the last we have 6 here, rest of 6 will remove the element from the list, so 6 will get removed, we have an empty list here. Now what will happen here? Still we need to call this one, so that will return A, right? So 1, so 2, then 4, then 5, then 6. Yeah, so that will be what? List only, right? Number of elements in the list, or list plus 1? Tell me. In the first
Sir,
call, we have
number of
removed 2.
elements.
Number of elements only, correct? Yeah. So answer will be what? Length plus 1. List plus 1 here. Okay. Which how 1? But the first
Number
we have
of
got,
elements to true, but also plus 1 for the initial call.
we have called this one. We have 4 elements. Then we have executed this one. Here we have remaining with the third one. Okay. So 1. Then again we are going to call this one for the second element. Again, you have to call this one for third element. Again, you have to call this one for fourth element. And when the list is empty also, again, we are going to call. Okay. So for empty list also, we are going to call. That is basically what? List plus 1 here. For one for each element, then for an empty list here. That is what? List plus 1 here. Okay. So length of list
But
plus 1.
if we
Yeah.
have the empty list, so if we have the empty list, we will return A, right? because length of L will be 0.
Yes. Whatever the value of A will be, that will get written here.
Uh, so yeah, so value that is the final value we get after the this procedure.
Yes, this is yeah, whatever the value here we are going to get. I guess it's the highest value if we compare with the every element, right? Yeah, highest value out of the list. That is what we are going to get here. So what are the value will be of A, that is what we are going to get here, return A. Let's see.
So if we get empty list, then we will return A and we will not go to that list because of A is not greater than the first A.
Sorry, if list is empty.
Yes,
Okay.
if list is empty and we will return A.
So what is the value we got A from the previous call? That is what we are going to return here.
Yes, sir.
Okay.
And won't go to the else.
Sorry, your voice is breaking. Is this for me only or for everyone?
Yes, sir, for me only. Me also.
Okay, fine.
Uh,
Okay.
sir,
Yes.
I'm saying that if return you have to go in the else block, then final value is the A, right? A.
Yes.
So
If the list is
the
empty
value
here,
A will be
we are going to return the value A because this will satisfy. Now, what is A? What are the value of A will be at that point of time, that will get updated here. That will get written. Okay. Let me take one example. Let's
okay,
take
sir.
next here. So you can see init is 6 and then we have what? 47385. 47385. And then we have 6. Okay. So init of A is basically 6. Then we have 47385. Right. 47385 now. Let me check. 47385. So this is the next question here. We need to find out the output of this one. So init, sorry, in int a, so integer a is given to us, that is basically 6, and list is also given to us. Let's see how many times we have to call and what's the output here. Okay, so this is the best way to understand. Let's see. Okay, so yeah, so this is basically 6 and this is basically list here. Now procedure, we are going to call at this particular point. Okay, first a, that is basically 6, and then list. Length of L, no, not 0, we'll go to else block. What happened here? Can anyone tell me what's the value of A? 6 here. It is greater than first of L. Is this true?
Sir, why it is 6?
Yes.
Sir, why it is 6?
We are discussing question number 6 here. So this is the question we are discussing.
Need of A is equals to
Yes.
6 is given.
Yeah. So question number 6 we are discussing. What about this one? First of L, first element,
4.
right?
4.
So 6 greater than 4?
Yes.
Yes. So we are going to update the value of A to what? Okay, 4. So that is basically 4. Now, if statement is over, we go to return statement. Calculate A. What is A here? 4 here, right? What is rest of L? Not 6, 4 here because it got updated. You can see in the previous line itself. Now this will be 7, comma 3, comma 8, comma 5. Again, we have to call this one, right?
Yes. Yes.
Now, again, after calling length 0, no, go to else block. What will happen now? A is basically 4, and first element is basically what? 7 now. Is 4 greater than 7?
No.
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 Go to return statement. A will remain same, but we have to remove 7. Rest of L. Again, we have to call this one. Now, 385.
So, sir, A equal
eh,
to 7.
not A equals to 7. This is not satisfied, right? 4 is not greater than 7. If this is true, then only we have to update the value of A. Otherwise, not. Right? So, we have removed 7 from here. Next is basically 385. Again, not equals to 0. Again, go to else block. The value of A remains same. That is 4. Now, what is the first value of this list now? 385.
3.
Is this true? Yes.
Yes.
Now we have to update the value of A to 3 here. Then go for next return statement. Again, we have to remove 3, update the value of A to 3 plus 1. Now we left with 8 and 5. Tell me what will happen 8, 5, and then A is basically 3 here.
Greater than
No change in
less.
A.
No change. A will be 3 only.
So not true. 3 greater than 8, not true. Again, we go to return statement, again 3, but here we have to remove 8. Again, we have to call this one, that is basically 5. What will happen now? 5 and 3.
No
So
change.
3 is not greater
again,
than 5.
yeah, 3 is not greater than 5. Again, not satisfied. We have to return what? A will be 3. And list will be what? What's the rest of 5 now?
Empty.
Empty.
Empty. Now you can see we
Empty
already
list.
calculate 5 times plus 1, right? Number of element plus 1, right? For empty list. Now see here. Now what about this one? Length of L is equal to 0. Is this true?
True.
Yes.
Yes.
What's the value of A?
Yes, sir.
3.
3.
So output will
3.
be 3. And how many times we executed? Number of element plus 1. Okay, you can see this number of element plus 1 for the empty list here. So answer will be C, and for this question answer will be 3 here, right? Is that okay?
Yes.
Okay, great. So try to solve this recursion question. Okay. So one question will be there in the exam, right? At least one question. So that's it, simple one. Let's try to solve this one. Okay. Yeah, so this is one more type of question. So this different types of question you can see here. First one, you can see what A will represent, what N will represent, like that. In the second case, a statement will be given to you. You need to find out the correct pseudocode for that one, like this type of question. In the third type of question, code will be given to you, required output will be given to you, but there will be some errors in the code that you need to find out, right? The fourth type of question will be like this here. So requirement is given to you and you need to fill the code as per the requirement. Okay. So see here, following pseudocode executed using the scores data set. At the end of execution of the pseudocode, first of this D and then in bracket C minus last of D in bracket C will represent difference between highest and lowest mathematics marks of the city C. Okay. Now what do you understand from this one? First tell me.
The value of DC is a
The
list.
yes. Value of disease list.
Yes, because first and last we use only for list, right? It means
Yes.
what? The output of this DC will be what? List here. This is what we know. Okay. Let's see now. Between the highest and the lowest marks of the city C. Okay, let's see. So here we have D is basically what? Empty dictionary. While table 1 has more rows. Okay, read the first row. Okay. What we are doing here? If is key city town D, what does this will check? We already discussed. It will check whether city is a key in this dictionary or not. But initially it is empty. So this is basically what?
False.
False. We go to else block here. What we are doing? Tell me what we are doing here.
Assigning
Adding two values, the same values for first and last.
Same values?
For that card, you're
Uh-huh.
saving that value in the
Hmm.
first and the second position.
So here both are mathematics marks only, right? But what is this mathematics marks here? X dot city.
It's initialized.
Yeah.
Are
So
you
see, let's say for example, we are only dealing with mathematics marks, right? So let's say we have 1, 2, 3, 4, 5 students. Then we have city and then we have mathematics marks. So 70, 80, 90, 65, 70 here, like that. City will be Mumbai, then let's say Chennai, and say Mumbai. Then we have Hyderabad, and let's say again Mumbai here. Okay, like that. Now for the first row, if city is Mumbai, then what we are going to do? Anyway, Mumbai is not part of dictionary. We'll go to else block. Now what is this one? Inside dictionary D, we are creating what? We are creating key that is basically city name Mumbai, and the corresponding value will be a list having the mathematics marks, that is 70 comma 70. Can I say like this? Is this correct for the first iteration?
No, I mean these should be the all the maths marks for the city, like 70
It's
and
for the first card. For the first student, since
and
it's not in the dictionary, it will
why?
store
We are only
both
dealing
values
with
as
the first
70
card here, right? X
Yes.
dot
because
mathematics,
it's
X dot
initialized.
mathematics, X is basically a same student only, right?
Yes.
Now we'll go to a next while
Then why we
loop.
are adding 2 times 17?
It's
You
not
can see
adding two positions.
we are not adding. We are
So
specifying.
in a list,
You can see X
2
dot
times.
mathematics.
We are taking 2 times.
Yeah, you can see X dot mathematics 70, comma again X dot mathematics again 70. It's a list here, right? So we are keeping a track of mathematics marks at two places here. Okay, this is what you can say. Now, if I go for a next iteration, next will be Chennai here. So again, anyway, Chennai is not part of dictionary. In the same way, we are going to create that as well. Okay, so if I just put here Chennai, okay, you don't need to consider the example in the exam. You can simply uh, fill the code. You can element the option, but to understand the example, I am just taking this demo things. So here you can see 80 comma 80 here, right? Now let's say, for example, if I go for a next iteration, next is Mumbai, but Mumbai is basically in the list, right? In the dictionary, right? Mumbai is the part of the key here, you can see. So this is true. Now, if this is true, we need to fill the code. But for what? In such a way that the first of this D of C, what is C here? C, let's say, for example, city C, that is Mumbai, minus last of D of Mumbai will give me what difference between highest and lowest mathematics marks. What does this mean? We have two elements in the list here, first and last. This is first, this is last, right? So first must be what? Difference between highest and lowest mathematics marks. So this should be what? First element should be what?
Highest
The
mark.
highest
Highest
marks in the
marks.
city.
Yeah. So this should be highest and lowest like this, right? Hello?
Yes.
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 Now we need to fill the code in such a way that this will give me highest at the first position, lowest at the second position. That's it. Now let's see the options. Is option A correct? We are dealing with Mumbai only. Okay, let's say Mumbai only. So Mumbai here. So D of Mumbai. So current value of Mumbai is basically what? 70, right? Greater than what is the value we have for that particular row. That is basically 90 here. So if I say that is 90, is 70 greater than 90?
No.
No. What about this one? What is last of this one? So last of is again 70 greater less than 90. Is this true?
Yes.
Yes, sir.
Now what we are doing here for that particular city, first of this one. So this will store the first element, that is 70 here, and this will store the mathematics marks, that is 90 here. Is this correct? Do we want like this?
No.
We want 90 on this side, 70 on this side, right?
Yes.
So not correct. What about B?
Yes, true.
Yes.
See here. This is what are the current value we have. That is 70, first element here. Less than 90. This is true. Yes. Now for that city, what we are doing? The current value, the last value, that is this is 70. So 90 comma 70. So 90 at the first place, 70 at the last place. This is what we want. Yes. Okay. Let's see the line number 4 as well. Last of this is basically a 70 as of now. Then we have what? This is 90. So not true here, right?
False.
So that is false. So this is what we are going to get. Okay. This looks correct, but what if we have a different criteria? Let's say, for example, instead of 90, we have 60. In that case, also option B should work. Can you check for that criteria? Instead of 90, if we have 60. X dot mathematics equals to 60 instead of 90. So this is basically what 70 less than 60. Is this true? No. 70 greater than 60. Is this true? Yes.
Yes.
So for Mumbai, what is the first here? 70 only. And the current value is 60 here. So we got highest and lowest, current highest, current lowest, right? So yes.
Yes.
So both the case, we are going to get the same thing. So option B looks correct. So multiple options can be correct here. I guess MSQ question here. Let's see. Option number C, tell me, is this correct? Option number C, tell me, is this correct?
No, sir.
Let's see here, last of this one, right? So again, 70, then we have, let's say, we'll deal with the 90 only. Let's see. If this is correct, then you will replace with 90. This will replace with 70. This is correct. What about this one? 70, 90, no. Right? So in the case of 90, it is working fine. What about 60? So this is 60, sorry. This is also working fine, right? What's the difference here? B and Z?
You're checking last of D, but you're updating first of D in C.
Sorry, can you repeat?
In the if condition, you're checking the value with last of the list of but when you're updating it, you're updating the first.
Yes, correct. So if I take the 60 as the current value here, let's for example here 60 as current value, 70 as here, then we're updating the last value here. That is basically 70. So this will give me 60. Okay. Here what will happen? 70, but okay. 70 and 60. So we are updating 70 and then we are updating this one. So this is working here. In the case of 90.
If you take first and last as two different values, then it will give the wrong number.
Correct.
First is 90 and last is 70.
Yeah.
You put 60, then it will give you the wrong number.
So after line number 3, if I check for line number 5, so in that case 90, 70 will be there. So 90 and 70 will be there. And then next is basically 80. So if I go in that case, so last of D will be under 70 and here current is 80. This is basically true. So here we have 80 and this will be a last of 70. So yeah, it is going to update what? This one. Instead of 90, it is going to update 80, but that is not correct here. 90 is the highest. This should not happen, right? So this is not correct here. Yeah. Any doubt here why option C is not correct? कोई है उधर? 22 students are there. Anyone, any doubt why option C is not correct? If you look
Sir,
at if two.
Can you explain again option C?
Yeah. Let's say for example.
So how to take these cases, because all cases don't hit no at that time. So
Yeah. So
logically it seems correct, the C1, but when you go to that particular case, then only we can see that it is not working.
if you look at this particular case, the two values are different. In that case, only this will give us false value, right? So for that, you need to take the multiple possibilities here, right? Like this. Okay. So try to practice more here. So first, anyway, we have started initially with 70-70, but it is also possible that next addition will be 80-70. In that case, also this should work. Option B will also be in option B will that work because we are going to update the last here. Here we are updating what for this criteria. We are checking for first and then we are keeping the last here. Yes. Okay. So we need to take the different combinations here and then check each option. So try to do more practice. What about D? Is this correct?
Sir, for option C,
Yeah.
how is it updating the last value? Like, I don't understand why is it wrong.
Okay. So let's say, for example, initially we have 70-70. Then at line number 3, we got highest mark, that is 90. Right? So update will be 90-70 like that, highest and lowest. Right? Now here we have 60 here. Let's say, for example, right? Here we have 60 here, not 60. We'll take, yeah, 60 here. Now see, if I take this combination, if I take mathematics current is 60 here, what will happen? 60 and then we have last of these basically 70. So not correct. Last of D. Yeah, we'll go to here. First of D is basically 90. Here, last of the current mathematics is 60 here. So this is true. So here we are updating first of these basically with 90, and here mathematics is basically 60. So for lowest, this will also work. But if I take 80 here in between,
Middle value.
yeah, in between that value, in that case, it just will not work, I guess. Yeah. If I take 80, this is basically 70. So 70 less than 80, yes, true. And we are updating with the 80 here instead of 90. That should not happen because it should be highest value only. So for in between value, between current highest and current lowest, if we got that value, so for that case, C will not work. Okay? Yeah. So difficult option to eliminate. Yeah.
Got
So
it.
just try to take all the possibility here. Yeah. You need to check all the possibility for such type of questions. Yeah. What about D? You can check here, right? Same thing will happen here as well. I guess instead of this one, we are updating this one here. Right? Last. Okay. So try to solve this question again. Oh my God, we have so many questions. Yeah. Let's try to solve this question. Yeah. So see, we have few questions based on the graph also. If you want that, we can go to that question as well. Because it's not possible to cover all the 20 questions. So we have few graph questions as well, like that. Okay, so we'll complete one more question, then we'll go to graph question here. This question is based on what list here, but it looks what? Yeah, let's try to solve this one. Yeah, you can see we call two sentences similar if both of them have same number of words and satisfy the following condition. Now read the statement carefully what it is saying. Similar sentences if both the sentences have same number of words. Okay, so first thing is number of word must be same. Second condition is basically this one. Ayat word in the first sentence has the same part of speech as the ayat word in the second sentence. Right? For example, for you can see I between 1 to L here, where L is total number of words in the either sentence. So that particular word in the first sentence has the same part of speech as the word in the second sentence here. Okay. A list, B list are the list that contains the part of speech of the words in the two sentences A and B respectively. So it contains the part of speech of words in two sentences A and B respectively. This similar is a procedure that accepts two lists as parameters and checks for the similarity of A and B. So two conditions are there. First, number of words must be same. So we need to check the length of that particular word. That's it. If it is same, then only we can throw it. Otherwise, it is simply false here, right? Second condition is that part of speech of that particular in that sentence, ayat word must be same here, right? Let's say, for example, third one is noun. So the second sentence also third word should be noun. Okay, like that. I hope the criteria is clear. Anyone, any doubt in this in the statements? Okay.
Clear, sir.
So only two things: number of words and then part of speech should be same. That's it. Now, what about option number A here? Is this correct? Length is not same. We are going to return false. That's it. What about the second criteria? We are
Yes,
checking the part of speech.
yes.
Should be same in the same order. Huh?
In the second part, we are checking each X in A list, but we need not to do that because we want every element to every element like copy. So
Part of speech must be same, right? Huh.
yes, part of part of speech must be same. So this option is not true.
It looks okay.
So this is
X first of C
simple
list
one,
will
right?
check first of each.
First of
And
each,
then it will
okay.
remove one element of each and
If
go to the next element of A list.
if X is not equal to first C list, then return false.
Yeah, anyone isn't equal, it will return false. Otherwise, it will go till the end. And till the end, if it doesn't return false, it will return true.
See here we have a for loop, right? Now what we are doing here, we are creating a copy of B list in C list here. So C list will have all the values from B list here. Okay. Now for each value, that is basically X in the A list, what we are checking here? If X not equals to first of C list here. So A list and C list we are comparing. So C and B basically same list here. Okay. Now see what we are doing here. If the part of speech of the first word, right, is not matching with the part of speech of the first word from the second list here, then we have to return false. Is this correct?
Yes.
Yes. But if it match, then we don't need to go. What we are doing here, if let's say first word is noun, here also noun here. So noun got matched. So anyway, this is not correct. We'll go to C list here. We are removing what? The last element, sorry, the first element here.
First element remove.
Yeah. So for loop will go from first, second, third like this. And here we are removing the one word from the C list. So in the next iteration, X will be a part of speech of second word. And here we are dealing with what? First of C list will be again part of speech of second word here. Right? Are you getting my point, what I am saying?
Yes.
First of the rest of the C list.
Yes. So we are going in this direction, first word, second word like that in the A list. And here we are removing one verb or sorry, part of speech from the list here. So anyway, we are comparing the part of speech at the same position here, right?
This is where I got confused because here for each X in the A list. So what I think for each X we are comparing every element of the other list. That's why C list every time got updated.
Yeah, let's say for example, here we have noun, verb, then let's say adverb. Again, we have noun. Again, we have adjective. Let's like this. Here also, second list is basically C list. Here we have A list, noun, verb, adverb, and let's say here adjective. Okay, instead of noun. And here we have noun. So till this one, it should work fine. For the next part of it should be false. Okay, let's see here. So for each X in the A list, that is basically, for example, first iteration X will be what? Noun here. Now, noun is not equals to first of C list. Noun is not equals to noun. Is this true? No. So we'll go to C list. we have to remove the first element from the C list. So we have removed noun. Go for next iteration. Now next iteration, X will be what? Next element of the list. That is basically verb. Now is verb is not equal to the first element of the list. That is basically verb. Again, not true. We'll go for a C list. Again, we have to remove like this. So in this way, we are comparing next next part of which will be a what? Adverb. Again, comparing with the adverb. Again, not satisfied. Again, we'll remove this one. Now let's see what happens for the next iteration. Next will be my noun in A list. But here we have adjective. So noun is not equal to adjective. Then we have to return false.
Okay, got
So
it,
for
sir.
first
X is
three words,
also moving.
yes, X is also moving one by one. First we compare this, then this like this, right?
Yes, yes, yes.
Option A looks correct. Let's go with option number B. Anyway, this is don't need to just simply check this condition. If it is not equal, then it should return false. That's it. Now what we are doing here? If part of speech is
Here,
equal to the first part of speech, then we are returning false.
false.
Do we want
Yes.
that?
No.
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 Option B, no. What about C?
It is also
Don't
incorrect because
don't check this condition only. See what we are doing here. Okay. So anyway, we have discussed in the previous option. That's why we can easily say that is option B is not correct. But what about if I just replace this rest by init? So in that case, okay, anyway, it is not matching. So equal to return false. So yeah, this will not be a true. Let's see for option number C here. This is fine. C list for each X in A list, what we are doing? First of
Return
C list,
true is
we are
wrong.
going to
Re-
return true.
yes.
No, we don't want to
Yes.
return
Just one.
true here. What about D? This is fine. Again, equal.
X is equal to last
Init
of C
C
list.
list is wrong.
Here also we are comparing with the last. But anyway, we cannot find the order here, right? First and the last part of which this is not the requirement is. Anyway, it's going to return false. So option D is not correct. Only option A is correct here. Okay. Okay. Great. Yeah. So this type of question you can expect. Now let's try to solve few questions from week 9 onwards. What happened? Let's go to the graph question here. Graph. Chalo. Okay. So week 9, 10 deals with the graph concept here, right? So you can see we have a node 0, 1. So if I have I node, if I have J node, if I have 2 node, so if there's arrow here like this, it is basically a directed graph. What? Direction is given to us. It means what? I can go from I to J, but not J to I. Okay. If the diagram is like this, I to J, and here we just have one line here without the arrow. This is what? Undirected graph here. Undirected. It means what? I can go from I to J and J to I as well. This is basically directed, undirected graph here. What adjacency matrix here? Now, whenever this H from I to J, in the matrix will represent by 1 here. Whenever this H from I to J, it means I can go from I to J in the matrix M for the row I, for the column J, I am going to add 1 here or update by 1 here. Not add 1, update by 1 here. If I can go from I to J. But let's say, for example, in general, if we have some weights here like this, then we update that 1 by weights here. Like that also we do. Okay, but here we are just dealing with the unweighted graph, so we'll keep it as 1 here. It means what? This will give me information. If I say M 3, 5 equals to 1. If I say this is the thing in the statement, it means what? I can go from 3 to 5 here. Okay, you can see like this. Okay, so the concept of adjacency matrix is clear. We have discussed in the
Yes.
last session. I have taken the last session. We have discussed this in detail, so you can check out that. So adjacency matrix, you should know. Directed, undirected graph, you should know. And what is degree of the vertices? Degree of vertices or node we can say. So first is basically what? Total number of edges, incoming plus outgoing. So we have two things here. In degree. In degree means what? Number of incoming edges. Incoming edges. So if I take this node 0, how many incoming edges? Only one. In degree of node 0 is 1. If I say out degree here, that is basically number of out degree edges. How many out degree edges? Outcoming edges? 2. So out degree of this particular node is 2 here. Now when I say degree of the vertex, or we can say node here, that is basically in degree plus out degree here. That is basically 3. So number of incoming and outgoing arrow is basically degree of that particular vertex. Okay. So remember this point. Is this clear about the degree?
Yes.
Okay. There is one more concept called click. What is click? Can anyone tell me?
Every node is
Is
connected
that are
to
connected to each
every
other.
another.
Yes. In the graph, every node is connected to every other node. So if I say 1, 2, 3, so 1 is connected to 3, 2 as well. Similarly, 2 to 3, 3 to 2, like this. So this is basically click of size 3. Size 3, or we can say node 3. So here we have 3 nodes here. For the 4 node, it will be like this. So 1, 2, 3. Will this form a click?
No.
No.
No. 1 is not connected to 4. This is not connected to 4. So this will form the click because every node is connected to each and every node here. And in the case of click, the degree of each and every vertex will be the same here. Here also 2, 2, 2. Here we have 3, 3, 3, 3. Okay. So for this is basically size 3, size 4, and size 2 is basically simple one like this. Okay. I hope the concept of click is clear. Now let's try to solve the question here. So this is what we required in the graph here. So you should know adjacency matrix. That's it. Now let's see the pseudocode first. Okay. So we'll come to a graph, but let's discuss pseudocode. Do something. M. What is M? Adjacency matrix for this particular graph. Q. What is Q? It can be a node, I guess. Let's see. Count equals to 0. Okay. For each I in rows of M. Now see, rows of M or columns of M is basically what? So this will give me what? List of vertices. Okay. List of vertices of this particular graph, given graph for the for which we are representing M. That is basically what? Starting from 0, right? Yeah. 0, 1, 2, 3, 4, 5. Okay. So rows of M or columns of M will give me what? List of vertices. It is 0, 1, 2, 3, 4, 5 for this graph. Okay. Is this clear?
Yes.
Yes.
Yes, sir.
Okay. Now what we are doing here for each I. So let's say for example, I basically 0. So 0 and Q we have some, let's say for example 5. Q equals to 5. So 0 to 5 equals to 1, or 5 to 0 equals to 1. Then we are going to count the value here. It means what? If we can go from 0 to 5 or 5 to 0, in either of the case, we want to increment the value of count here, right? So can anyone tell me what should be the value of count here for the given graph when I say Q equals to 5?
0.
1.
1.
1?
No, 0,
Yes.
because 0 to 5 incoming, outgoing edges we are looking for. So 5 to 0
No.
there is an edge, but 0 to 5 there is no edge.
0, it will be,
Yes, sir.
count will be
Q equals to 5, right? So when I say Q equals to 5, Q is fixed, right? Now I will start with 0. So 0 to 5, do we have edge? No. 5 to 0?
Yes.
Yes, sir.
Yes.
So
2.
this is true,
That is
right? So
2.
we have to
Yeah.
increment the value of
Outgoing edges.
count.
Okay,
1.
or is written here.
Yeah.
5 to
Go
0 and
for
5 to
next iteration. 1 to 5. Next is basically 1 after 0, right? Next element is 1. 1 to 5, 5 to 1. No. Both are false. We go for next iteration, that is 2 here. 5 to 2, 2 to 5.
5 to 2 there is an edge.
5 to 2.
So
Yes, sir.
count will
No,
be
no. See,
looking.
No, did you understand why I have gone for 2? Because we are in the for loop. First I equals to 0, then I equals to 1, then I equals to 2 now. When I say I equals to 2, so we are checking for 2 to 5, 5 to 2 like that. So 2 to 5 not possible, but 5 to 2 possible.
Yes.
So our statement is there. So we are going to increment by 1.
Yes.
Yes. Go for next iteration. The value of I is 3 now. 3 to 5, 5 to 3, which is possible. 3 to 5. So
Yes.
this will
3
be
to 5.
true.
So count will
Again
be
3. Next iteration 4, 4 to 5, 5 to 4. No.
no.
Next iteration 5, 5 to 5, 5 to 5. No. Next iteration, we don't have any other element. That's it. The answer will be 3 in that case. Okay. So see, whenever you see this one equals to 1, it means I can go from I to Q. What are the value of Q or I is given to you? You are dealing with the I. So that is what you need to check in the graph. That's it. Okay. I hope the procedure is clear. Now let's
So,
see.
sir, for a particular vertex, we are checking for only from one particular vertex to other vertices.
Yeah. For a given value of a Q here, we are checking that. Like how many incoming and outgoing edges we have. This is what this code is doing here. Right?
Yes.
So if I say I to Q, means I can go from I to Q in the graph. So there's a direct edge from I to Q equals to 1. This is I, this is Q, you can see like that.
This statement is clear, but I wanted to know. We are checking for a particular vertices that vertex is connected to other one, or for every vertex we are checking.
Now for this particular vertex, right, Q?
So it can be any one of them.
Yeah, it can be any value here. Right? So what we are checking here for a given vertex, it can be a Q. If we have edge from I to Q or Q to I, then only we are going to increment the value of count here. Okay. So see, I to Q means direct edge. It's not like that 4 to 1 I can go via 3. No, it's not via 1 hop. It's a direct edge we want. Okay. It's the graph. Let's see here. Okay. What about do something m comma 4? So the value of v is what we need to find out. Now tell me for m comma 4, what's the value?
2.
2.
2. Simple. So in number of incoming, outgoing, like for I equals to 3 and 2, this will get satisfied. So the value will be what? 2 here. You can see answer is 2. Simple one. Next is basically what? M comma 5 already discussed. That is basically 3 here. Right? So see, the
Sir,
graph
how
will be
it is?
given.
Sir, m comma 4, how it is, sir? M comma 4, how it is 2?
Yeah, see, again same thing. Here, instead of Q, instead of 5, we are dealing with 4 here. So this is basically 4, this is basically 4. Now we're iterating over a for loop. So for I equals to 0, 0 to 4, do we have anything? No. 4 to I? No. So for next iteration, 1 to 4, 1 to 4 to 1? No. So for next iteration, 2 to 4? Yes. So we have 2 to 4. Here you can see I the value of I, and then that is equals to 1. So or 4 to 2? No, but or condition. So we are going to increment the value of count here. Again, next iteration, the value of I will be 3. Again, 3 to 4. 3 to 4, no, but 4 to 3, yes. Then we increment the value of count like that. Okay.
Sir, we should check for 1, 5, and 0 also.
Yes. If you understand what the pseudocode is doing, then you don't need to see, because if you observe, we are simply finding it out how many incoming and outgoing edges this particular node has. That's it. For 5, it is 3. For 4, it is 2. For 1, it is 2. For 0, it is 3. Like that. For 2, it is 3. Like that. Okay. If you understand what the pseudocode is doing,
What is the value of count?
value of count for the case like for q equals to 4 will be 2. Okay.
Yes.
So simply we are finding
4 के लिए पूछा गया है.
हाँ 4 के लिए. And the next question 5 के लिए पूछा गया. That is basically 3 here. But we have discussed. So you can see
That's why,
here.
sir, we have to check for 3 vertex.
Yeah. So better to follow this procedure only. So for each I, for every vertex, just check whether we can go from this Q to that vertex or from that vertex to Q here, like that. So keep iterating over the value of I here. So see, the graph will be given to you and the pseudocode will be given to you. So this type of question you can expect. Graph may get changed, pseudocode may get changed slightly. Instead of or, it can be and. Instead of one for loop, it can be a multiple for loop, right? If you observe in the last session, I have discussed similar question where multiple for loop was there, but graph was different, right? So given a graph, given a pseudocode, you should be able to answer the question. That's it. Okay, okay, great. Let's see. Now, this is also we have discussed in the last session, but with the different diagram. Same pseudocode was there. If you remember, someone asked from the grade assignment question, right? Question number 9, if I remember correctly, or 11. We have discussed that. Same question, just we have changed the diagram. That's it. Okay. So again, try to solve this type of questions here. Pseudocode will maybe change slightly or graph will get slightly, but you can understand the concept. Then only you can solve those type of question. Let's try to discuss this question as well. So you can see the nodes here, adjacency matrix already computed. Here you can see. So 6 by 6 is a square matrix, right? The pseudocode is given to us. Now what we are doing initially, D is basically empty, L is basically a list here. What is this one? Can anyone tell me what we are doing at line number 3?
We are searching a path from 4th.
Yeah, so in the dictionary, it is initially empty, but at line number 3, I can write like this, 4 corresponding value -1. Is this correct?
Yes, sir.
Yes.
Yes.
Now let's go to line number 4. DL, okay, we are going to get this D and L from this one. What is this? This procedure. Now, what is M? The adjacency matrix. What is D here? Dictionary. What is
Dictionary.
L? List. And
List.
4
List.
is basically a node here.
Node.
So if I call this is basically my M. This is basically P is basically a D. And S is basically a list, which is initially empty. And I is basically 4 here, right? Now we need to execute this one. Let's see how it goes. Okay. Now line number 6 here, S equals to S plus plus I. So what we are doing here, initially S is empty, but what's the value of I? Initially
4.
4.
4. It means what? We can add 4 here in the S, right? Right?
Yes.
What about line number 7? Columns of graph again 0, 1, 2, 3, 4, 5, 6. No, 5 only, 0, 1, 2, 3, 4, 5. List of vertices. So we start with j equals to 0. Now value of I is fixed here, that is 4. Okay, 4 here, right? Now let's see.
Yes.
J will start with 0. 4 to 0, do we have 1?
No.
No.
False. No need to check for second condition because it's AND statement here. Next addition, j equals to 1. 4 to 1, do we have any edge?
Yes.
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 Check for next condition. And is there not j? What is j? 1 is part of the dictionary here. Is this the key?
No.
This is basically initially. So this is basically what? False. But what is this?
Not a
Not
false.
a
Not
false.
a
It's
false will
true.
be true.
True.
Again, so this is true, both are true. What we are doing here, tell me. P of j is basically what? 1 equals to 4 here. I is 4, j is 1. What we are doing here? We are adding the key inside the dictionary with the key 1 and the corresponding value 4. Can we say like this?
Yes.
So 1 corresponding value 4 here. So this is what we got here. Now what we are doing here? Search path. Again, we are calling the same procedure inside the procedure, but this time what's the difference? Here we have
J.
J is 1.
graph same, P is got updated to this one, S got updated to this one, J is basically what? 1, right? So see, we have started with this node, now we went to this node here, okay? It's a DFS thing, it's a different thing, depth first search, it's a complete algorithm, okay? So here we are not going into that, just understand the pseudocode. But if you look at our diploma level course, in that we have PDSA course, data structure course. In that you can see DFS thing. So same thing, same concept is here as well, okay? But in that course, we'll apply a Python code here, not the pseudocode. Okay, this is using recursion here. So first we have started with the node 4, then we have went to node 1. You can see here. Now again, I'm calling this one. What's happening? Is this lacking if I'm writing? Fine.
Sir, fine.
Okay, fine. So see. Okay. Now see, now the value of J, it is basically 1 here. Now we have to call this graph again. Sorry, this procedure again here. Now value of I is basically 1 now. Now tell me what will happen. Here instead of I, we have 1. S is this, P is this, and graph is given to us. Again, line number 6, we are going to add what? 1 here, right? So 4 comma 1 will be that, plus 1 I can add. It is basically 4 comma 1. What will happen line number 7? Now you tell me. For which value of I this will get satisfied?
0.
Sorry, for J. Because I is fixed here, that is basically 1 here, right? Now tell me. We'll start with 0. J equals to
J
0.
Yeah, I0 is
Yes, 1 to 0 you can see here. We can go. And
4.
no,
1 to 5.
First we're dealing with J only, right? That is 0. So 0 is a part of dictionary.
No.
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 False, not of false, true, true and true, true. What we are doing here, J is basically what? 0, value is 1. So we are going to add 0 here and the corresponding value will be 1. Is this clear? Updated dictionary.
Yeah.
Now what is the value of J? What we got? 0 here, right? 0, na? Again going to call the function here. Now see what we are doing. From 4 to 1, we have gone to 0. Right? Now let's see here 0. What will happen now? Tell me. Again, we need to call the same function here because we have not written anything yet. Again, this is for 0 now. This is basically 0 now. I will add 0 here. Now tell me after this one, for which condition it will get satisfied.
0 to J2.
This is
0 to 2.
basically for J. First, we need to start with 0. J equals to 0. No. J equals to 1. What about J equals to 1?
We will not take this because it is the
His
key
key will
already.
be false.
So 0 to 1 we can go, right? So this will be true. But what about this one? For the value of J, that is 1. 1 is the key of this dictionary P. Yes. That is
Yes.
basically true. Not of true will be false. So this will be a false and this will be a true. So entire question becomes false here. So that's why for J equals to 1, we cannot proceed, right? Because dictionary 1 exists. Okay. Now, what about J equals to 2? Next value.
Graph is true.
Can
Not
we go
true.
to 2?
Yes.
Is 2 is a part of dictionary?
No.
No. So what we are doing in the dictionary, we are going to add 2, corresponding value will be 1, right?
Yes.
So J
Yes.
will be 2 now. Let's see here, right?
Sir, corresponding
You have
value
to
will
update
be
S also.
0, no? For 2.
Sorry, can you repeat?
Sir, for 2, the corresponding value will be 0.
Sir, 1 is not connected
Not
to
1.
2.
No, what
In the
we are dealing
dictionary,
with?
so in the dictionary, For 2, we will not put 1, we'll put 0, right? The value for 2, key 2.
2:0. That's what they're saying.
Just
It's
a
coming
second.
from 0.
The value of I is what? Okay, so we are dealing with I
0.
equals to 1. So 1 to 0,
2:0, sir.
we can go, but already wait, what I have done here, we have gone to 0 here, right? This was 2, na?
Dictionary 2:0 it should.
In dictionary D 2:0.
2:0. Because this is basically 2. And
We
this is
fixed I to
basically
0 and then went J1
okay,
to 0 and
now
2.
got it. So here we need to add 2 as well, right? In the next
Yes.
iteration now. Yeah. So this will become my true here. Now let's see. Hmm. Now what will happen for j equals to I equals to 2 now? We have added 2 in the list. Now what about this one?
Now 2 to 3 we will go, not
2 to
0.
3 is the only option.
So 0 to we go to 2 here, right? Now let's see if I have the value of I to 2. Now what about j? J will start with 0, but anyway 2 to 0 I can go, but 0 is already part in a dictionary. 2 to 1, no. 2 to 2, no. 2 to 3, yes.
Yes.
It's 1, but 3 is not in the dictionary. So that is false, and not of false will be true. So 3 and value will be what? 2, right?
2.
So this will be 3:2 here, right? So this is what we need to do here, right? Now the value of j becomes 3. So 1, 0, 1, 2, 3. Okay, na? What is remaining? 5. Okay. Now the value becomes 3 now here because we have at this particular point now. Now tell me what will happen if the value of j is now 3. So value of I is now 3 here. We got this dictionary, we got this list here. 0, 1, 2. At line number 6, we are going to add 3 in the list. So let me write it down. Let me remove this. So S is basically what? 4, 1, 0, 2, 3. Now here we have j equals to, sorry, I equals to 3. Now tell me what will happen now.
It will
3, we can't go
We'll
anywhere.
go through all j's from 0 to 5, but nothing can be updated, so we'll go back to the previous call.
Yeah. So first start with j equals to 0. 3, 0, no. 3, 1, no. 3, 2, yes, I can go 3 to 2, but 2 is already in the dictionary. So false. 3 to 3, no. 3 to 4, can we go? Yes.
Yes, but 4 is
4 is
already
already in the dictionary. Okay. What about j equals to 5, 3 to 5? No. So what will happen here if all the cases got failed? So we are not going to get through here. So we are going to exit the for loop here. Is this correct, or what will happen here? That's it. Do we need to exit the for loop?
Yes.
No, for I equal to 3, it will exit. It will go back to the previous, where I was 2.
Correct. So still we are inside for the for loop when the value of j is 3 here. Okay. If you remember, what's the value for this I which got satisfied? Which one? Here we can check 2 here, right? So previous value was 2. This was 3, right? 2 to 3.
Yes.
Yeah. So you can see when the value of j was 3, it got satisfied. Okay. Then we went for this particular thing. Now, what about value of j equals to 4, j equals to 5? So this for loop is yet to be completed. For node 3 is yet to completed. For node 2 also it's yet to completed because we have completed for j equals to 0 only. Right? So again, we have to backtrack for each and every node here. But if you observe, this will never get satisfied because only 5 is remaining here, right? So we cannot go 3 to 5. So after j equals to 4 or j equals to 5 also, we don't have any possibility. So we'll backtrack to previous explored node 2. So from 2 also, we already explored all the nodes. We'll go to 1. Now Sorry, 0. 0
0.
also we already explored. Go to
1.
1. But from 1, if you observe, we have went to 0 here, right? For j equals to 0, if you observe.
Yes.
So you can see this dictionary here, right? Like this. It means what? For the for loop, j equals to 1, 2, 3, 4, 5 is still pending here. Now, if I say j equals to 1, 1 to 1 I cannot go, 1 to 2 I cannot go, 1 to 3 I cannot go, 1 to 4 I can go, but 4 is already inside the dictionary. 1 to 5 I can go, right? 5 is not in the
Yes.
dictionary here, like that. So this will be a what? 1 to 5. So what is 1?
I is 1, j
Then
is 5.
I will be I is 1, j will be 5. So this is 5 and 1 here. So this will be 5 and 1. Here we have to add 5 here. Okay, so this will be my list. This will be my dictionary here. It is little bit a difficult concept to understand. DFS, it's algorithm up topic here because it's a backtracking thing. We have went to previous unexplored node here. If you observe what we have done, first started with this one, then went for this, then went for this, then went for this, then went for this. But at this point, all the nodes are already explored here, and we don't have any other nodes here to explore. Then what we will do? We will backtrack to previous unexplored node, again previous unexplored node already explored, again previous unexplored node already explored, but for this node, this is remaining here. So we'll explore this particular one. Okay. This is what DFS is, very, very important algorithm. If you look at entire data structure part here, DFS, VFS, these are the basic things. But if you understand this backtracking of algorithm here, don't worry if you don't understand the concept, but if you're able to understand this pseudocode, that's it. Okay. So answer will be C. What's the value of L? L is basically a list. 410235. 410235. 410235 option B. And the dictionary will be what? 4 minus 1, 4023. That is what we have here. Okay.
Sir,
So it's a
sir, like I understood the code, but I am just asking, like, how do we keep track of like the backtracking? It's quite complicated when we just get the code.
that is where this dictionary is useful here. Now, what this list will give us, this will give us order in which we have explored the node. Okay, starting from 4, 1, 0, 2, 3, 5. Is this fine about the
Yes.
list?
Yes.
What about dictionary is telling us? We have started with 4, then we have went to 1, but for which value of j we satisfied? 4 here, right?
Okay.
Then we have went to 0, but for which value of j? 1 here, like that. So we need to explore the value for j equals to 5 here as well, for here 2, 3, 4, 5 as well, here 1, 2, 3, 4, 5 as well, like that, right?
Okay, got it.
Yeah.
Sir,
4 to 1, sorry.
why we have taken 4 to minus 1? Sir, in the text study.
It's an initial thing. Initially, we have started with the node 4 here. That's why we can start with any other node here in the graph.
Sir,
If I start with code 5, I can write like this. So we'll start with the node this one, like this.
Sir, why we have taken negative value -1?
That any value we can take here.
To identify the first
vertices are
node.
from 0 to something.
All others
so
are
yeah.
So we'll take negative.
Yeah. So you can see we have started from this particular node, so we have taken this as negative.
Yes, sir. So like we are considering for taking if we assume a is equal to 0, or for minimum we are taking 1000 or 100. In that way,
Yes,
we have taken minus.
Either we can take the negative or index out of this particular range, 1 to 5, whatever we have, 100 or like that we can take. Best way to take the negative here. Okay.
Yes.
Because we don't know how many x's can or how many vertices will be there in that. It's better to take it negative. Okay. So that's it from my side. So remaining question we can discuss tomorrow session, or in tomorrow session, if you have any doubt, you can ask the instructor. Okay. So thank you. everyone, and all the best for your end-term exam.
Thank you, sir.
Thank you, sir.
Excuse me, sir.
Huh?
So this PDF is available somewhere? Like it has all the
No,
different kinds.
it's a previous term QP. Instructor, as instructor, I cannot share that, but you can ask TA. They know how to get the previous year questions.
Yeah, that's okay. This one had all the concise ones, so I was asking.
Yeah, okay.
Okay, thank you, sir.
Okay, thank you then. Bye.